Ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kaalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWDR-FM. Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day.
Good afternoon to all our viewers and listeners, especially to our grade 10 learners. It's welcome to another fun-filled and great learning experience this afternoon with our scientific teachers via our radio station 106.3 FM Dance Radio and Facebook Dance Radio community. We hope you are already tuned in and are now ready to listen to our RBI lesson and later to participate in our live discussion. Okay, so without further much ado, here is our RBI lesson for the week.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta't magtulong-tulong, sulong edukalidad, Dance Radio.
Physics, Chemistry, Earth Science, Biology, Biochemistry, Environmental Science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is a way of helping the brain grow in finding new knowledge and help us defeat our curiosity of how the world develops and works today. Science, science, science. This is your class, and this is science.
Good day, our dear grade 10 learners, and also to those who are listening right now. I am Teacher Benjelu Paraiso, your radio teacher in science.
It's science time!
I hope everybody has tuned in and are now ready to listen and to learn our lesson today. Make sure that you are in a comfortable place and free from disturbances so that you can concentrate and able to understand the lesson. Are you ready in our discussion, my dear learners?
Yes, ma'am.
Can you still remember the different types of electromagnetic waves discussed in the previous module?
Yes, ma'am.
What are these types?
The different types of electromagnetic waves are radio waves, microwave,
infrared, visible light, ultraviolet, X-ray, and gamma ray, ma'am.
Yes, that's right. One of the most common among these electromagnetic waves is the visible light. In our discussion, you will study two of the properties of visible light: reflection in mirrors and refraction in lenses. Do you have with you your module for week 3?
Yes, ma'am.
What is all about module 3?
Module 3 is all about qualitative characteristics of images, ma'am.
That's right. After going through this module, everyone is expected to predict the qualitative characteristics such as orientation, type, and magnification of images formed by plane and curved mirrors and lenses. Before we start, I would like you to get a spoon and a variety of mirror if there's any. This will be used as we go through the lesson. How many times do you look at your face in the mirror in a day?
I look at my face in the mirror 3 times a day, ma'am.
Wow! While looking at your face in the mirror, have you ever asked yourself how your image is formed in the mirror?
Yes, ma'am. Aside from that, ma'am, I wonder how we were able to see our image in the mirror.
My dear learners, those questions will be answered as you listen in our discussion today. Are you now ready?
Yes, ma'am.
Okay, let's begin. What do you think will happen when you dribble a ball?
The ball bounces back as it hits the floor, ma'am.
Precisely. The same is true when light rays hit a barrier or anything that is opaque in nature or any object that does not permit light to pass through. The light rays bounce back in all directions as it hits the barrier. The light rays bounce back in all directions as it hits the barrier. We call this property of light as reflection. What is reflection?
Reflection is the bouncing back of light into the same medium it has been traveling after striking an opaque surface.
Correct! The light ray that strikes the surface is called the incident ray, and the ray that rebounds from the surface is called the reflected ray. What do you think will happen when light rays strike a smooth surface?
When a group of parallel rays strikes a smooth, flat surface, the rays are reflected parallel to each other, or they are in one direction, ma'am.
Very good! We call this type of reflection as specular or regular reflection.
Is this the reason why we can see our image in a mirror, ma'am?
Yes, you were correct. You can see your image in a mirror because of reflection. Another example of irregular reflection is a calm body of water. We can see our image on its surface. Regular reflection is an important principle in reflecting telescopes.
Wow!
How about if a group of parallel rays strike a rough surface?
When a group of parallel rays strikes a rough surface, the group of rays will be scattered in all directions after reflection, ma'am.
Very good! We call this type of reflection as diffused or irregular reflection. This occurs in rough surfaces such as clothing, paper, wavy water, and others. Diffused reflection is more common than regular reflection because the walls, the ceiling, the floor, and most of the objects inside our rooms are rough surfaces, so light rays scatter upon them.
Furthermore, ma'am, diffuse reflections enable us to see things around us. Some of the reflected light reaches our eyes after the light rays diffuse. Thus, we can see an object.
Aha!
This time, I like you to observe the image formed in a plane mirror. Bring a plane mirror in front of you. Raise your left hand in front of it. What have you noticed?
If I raise my left hand, I notice that the image would seem to be my right hand, ma'am.
Correct! When we say image, this is the visual representation of an object which is placed somewhere in front of a mirror or lens. How about if you raise your right hand?
If I raise my right hand, ma'am, the image would seem to be my left hand.
Yes, this is often termed as left-right reversal. Based on that, can you explain why the word ambulance in an ambulance car is written laterally reversed?
The letters in front of the ambulance are written that way so that when the word is seen in the rear view mirror by another vehicle, the image of the word would get inverted, letting the driver read the word properly so that he can provide way for the ambulance.
Very good! How about the size of your image? How will you compare the size of your image to your actual size?
My image is as big as my actual size, ma'am.
Correct! How about the distance of the image? If you move towards the mirror, what have you noticed on the distance of the image?
When I moved towards the mirror, my image also came towards the mirror, and when I moved away, it also did, ma'am.
Yes, that's right. Based on what you observed, can you describe now the characteristics of images formed by a plane mirror?
The image formed by a plane mirror is laterally reversed, same size, same distance, same orientation as the object. It is virtual, ma'am.
You are correct. You have already described the characteristics of images formed by a plane mirror. Let's proceed to another type of mirror. Have you looked at the side mirror of a car? How is it different from the plane mirror you are using?
The shape of the side mirror follows the surface of a sphere while the plane mirror has flat surface, ma'am.
Very good! Curved mirror is also called as spherical mirror. There are two kinds of spherical mirrors. These are the concave and convex mirrors. Can you differentiate concave from a convex mirror?
Yes, ma'am. Concave mirror is a curved mirror in which the reflective surface is the inward curve that bulges away from the light source, while convex mirror is a curved mirror in which the reflective surface is the outward curve that bulges towards the light source, ma'am.
Precisely! Example of concave mirror is the inside curve or reflecting surface of a spoon. And convex mirror is the outside curve of a spoon. Concave mirror is also called converging mirror. What is meant by the word converge?
Converge means to tend to meet in a point, ma'am.
Correct! Concave mirror is also called converging mirror because the parallel incident rays converge or meet or intersect at a point in front of the mirror called focal point after reflection. How about convex mirror? Why is it called as diverging mirror?
Convex mirror is also called diverging mirror because the parallel incident rays do not intersect. Instead, they diverge or go into different directions after reflection, ma'am.
That's right! The parallel incident rays diverge or go into different directions after reflection, but if you draw an imaginary line connected to the reflected rays behind the mirror, the rays seem to converge at the focus behind the mirror, forming virtual images.
Aha!
Now, let's discuss the types of images formed by curved mirrors. There are two types of images formed by curved mirrors. These are real image and virtual image. These images are formed due to the convergence of light rays at a point after being reflected from a mirror or a lens. How will you compare virtual from real image?
Real image is formed when light rays actually meet in front of the mirror after reflection, while virtual image is formed when light rays do not actually intersect but seem to intersect behind the mirror after reflection, ma'am.
Very good! Simply, we can differentiate the two as the real image, which can be formed or caught on a screen just like the images formed by a projector in a cinema screen. On the other hand, the virtual image cannot be caught on a screen since they are unreal images, just like the images we see in a side view reflector of a car. How will you describe the real image appearance of an object?
Real images are inverted in nature, while virtual images appear to be erect or upright, or they have the same orientation as the object, ma'am.
Correct! Now, based on those ideas, how can you differentiate the image formed between concave and convex mirror? What do you think are the types of images formed in these types of curved mirrors? My dear grade 10 learners, those questions will be answered after this reminder.
Uy, Pedro! Nagpabakuna ka na ba?
Oo naman, Petra. Bakunado na yata to. Dapat ang bawat isa ay mahikayat ng magpabakuna. Bata, matanda, tara na!
Tama ka dyan, Pedro. Kung may bakuna, siguradong protektado tayo laban sa virus. Kaya magpapabaksin na rin ako.
Tandaan, magpabakuna, siguradong protektado ka.
Isang paalala mula sa Doña Aurora National High School at ng himpilang ito.
It's Science Time!
You are listening to Teacher Benjulu.
We're back! Thank you, dear grade 10 learners, for still tuning in. Turn your module on page 15 titled Image Formed by Curved Mirrors. In this activity, describe the image formed in curved mirrors. Get a spoon that serves as your mirror. Look at the convex surface of the spoon. Observe your image as you bring the spoon farther from you. How do you describe your image as you look at your face on the convex surface of the spoon?
My image in convex mirror is smaller and upright, ma'am.
Precisely. What type of image is formed?
Since the orientation of my image form is upright, the type of image form is virtual, ma'am.
Very good. This time, look at the concave surface of the spoon. Observe your image while holding the spoon at arm's length. How will you describe your image?
If I look into the concave surface of the spoon while holding it at arm's length, I can see an extremely reduced and inverted image of my face, ma'am.
Yes. How about if you bring the spoon closer to your face?
The image of my face gets bigger and bigger, and it is upright, ma'am.
Correct. From that idea, how will you describe the image produced in a concave mirror?
The image produced in a concave mirror may be larger than, the same size as, or smaller than the object. A concave mirror also can produce real or virtual images depending on the distance between the mirror and the object, ma'am.
Good! We have described the image formed both in plane and curved mirrors. We continue our discussion when we return.
COVID-19 has caused loss of lives and economic hardship all over the world. It has changed our habits and the way we live while testing our public health systems and impacting on our livelihoods. With this, the role of environmental health practitioner has never been more vital as we face up to the ongoing challenges this pandemic. Many changes are about to happen for a greener environment, more equal and more stabilized economy. COVID-19 pandemic has resulted numerous impacts on the environment and climate. But amid this crisis, we have a chance to build a better community and environment. Hashtag healthy environment. Hashtag healthy community.
It's Science Time!
You are listening to Teacher Benjulu.
Welcome back! This time, let's discuss the terms we encounter in the study of curved mirrors. We have the term center of curvature. What is center of curvature?
Center of curvature is the center of the sphere whose surface formed the curved mirror, ma'am.
Correct! Another term is focal point. What is focal point?
Focal point or principal focus is the point between the center of the curvature or the center of the mirror and vertex, ma'am.
That's right! It is in the principal focus where the light rays meet. Its distance from the mirror is known as the focal length. Another term is vertex. What is vertex?
Vertex is the point where the principal axis meets the mirror, ma'am.
Yes, we have also the term principal axis, and that is the straight line passing through the center of curvature to the mirror. Last term is radius of curvature. What is radius of curvature?
Radius of curvature is the distance from the vertex to the center of the curvature, ma'am.
Very good! Those are the terms that we will be using in the study of spherical mirror. We have discussed that concave mirror produces different types of image depending on the distance between the mirror and the object. Turn your module on page 5. The first table shows a qualitative description of the image formed in a concave mirror in terms of its LOST at different locations of the object. LOST means location, orientation, size, and type of the image. If the location of object is beyond the center of curvature, how will you describe the image formed?
The location of the object is between C and F. The image formed is inverted and reduced, ma'am.
That's right. Since the image formed is inverted, the image is real. How about if the object is at the center of curvature? How will you describe the image formed?
When the object is at the center of curvature, the image is at C. It is inverted, same size, and real, ma'am.
Yes, and when the object is at the focus, no image is formed by the mirror. How about in convex mirror? How will you describe the image formed?
The image formed is always upright, reduced, and virtual, ma'am.
Correct! You can observe those when you perform Enrichment Activity 3 in your module. Can you follow, my dear grade 10 learners?
Yes, ma'am.
Before we end our discussion, let's summarize our lesson today. May I know the things that you have learned in our discussion, my dear learners?
I learned that there are two types of reflection, which are the regular or specular reflection and irregular or diffuse reflection, ma'am. Regular reflection is the reason why we could able to see our image in a mirror, ma'am.
That's right. Any more?
I learned the types of image formed both in plane and curved mirror, ma'am.
Very good. How will you describe the image formed in plane mirror?
The image formed by a plane mirror is laterally reversed, same size, same distance, same orientation as the object, and it is virtual, ma'am.
Absolutely. How about in curved mirror? How will you describe the image formed in curved mirrors?
The image formed in convex mirror is smaller, upright, and virtual, ma'am, while in concave mirror, the image formed in a concave mirror may be larger than, the same size as, or smaller than the object. A concave mirror also can produce real or virtual images depending on the distance between the mirror and the object, ma'am.
Precisely! What else have you learned?
I learned also the different terms used in describing curved mirrors, such as center of curvature, focal point, vertex, principal axis, and radius of curvature, ma'am.
Great! You really learned a lot. Keep it up! Let me check if you really understood our lesson. What type of mirror always forms images that are the same in size as the object?
Plain mirror, ma'am.
Very good! How about the type of mirror that forms images that are always reduced?
Convex mirror, ma'am.
Correct! How about the type of mirror that forms images that are either real or virtual?
Concave mirror, ma'am.
Absolutely! You are really great! Please answer this question, dear learners. Why are our two eyes considered the greatest mirrors we ever have?
Ma'am, our eyes are our greatest mirrors because they reflect the behavior we act upon from the natural surroundings we see.
That's true! Before we end up this session, I just want to leave this quote by Earl Nightingale. Our environment, the world in which we live and work, is a mirror of our attitudes and expectations. I would like to acknowledge the teachers behind this lesson. Teacher Teresa M. Seneca, our script writer. Teacher Rosabel R. Brillo, our language editor. Teacher Annabelle A. Rodriguez and yours truly, our content editors. Teacher Riza N. Marsan, our technical specialist. And I'm Teacher Benjulu R. Paraiso, your radio teacher for this hour. Thank you very much and stay tuned for our live discussion. Have a nice day, everyone!
Dance Radio, siniaralan sa radyo, atid namin makabago, paraan ang pagtuturo.
Wala nang makakapigil pa. Sulong Arangkada 106.3 Dance Radio sa Aurora, Isabela.
Edukasyo'y susulong, basta na magtulong-tulong, sulong edukalidad. Dance Radio, learning is amazing.
Physics, chemistry, earth science, biology.
Okay, so welcome back, my dear learners. Once again, good afternoon. And with us this afternoon are our scientific teachers to give us a better and deeper understanding of our lesson for this week. Okay, so may we hear from our Science 10 teachers. May we start with Ma'am Teresa.
Okay, so good afternoon to all our viewers and listeners. Especially to grade 10 learners. Special greetings sa mga hawak kong section, ang 10 Banaba, 10 Yakal, and 10 Bulate.
Okay, how about Sir Ronnie?
Hello, good afternoon po sa ating lahat. Okay, dito na ako.
Ang lakas na din si Sir Ronnie ngayon
Okay, malakas. Okay, so magandang tanghali po sa mga grade 10 learners sa 10 Nara, 10 Jemelina, at 10 Yakal, 10 Mahogany.
Okay, thank you Sir Ronnie. Yes, Ma'am Dines?
Okay, good afternoon everyone. Good afternoon grade 10 learners, especially to my 10 Tangile, 19 Dalo, and 10 Talisay.
Okay, thank you Ma'am Dines. Yes, Ma'am Jen.
Okay, magandang hapon po sa ating mga listeners this afternoon, especially to my 10 Kamagong and 10 Jimelina. Hello sa inyo dyan.
Okay, thank you Ma'am Jen. And ulitin daw natin tawagin si Ma'am Teresa kasi hindi raw po siya narinig kanina. Yes. Nakalimutan gumamit ng mic. Yes, Ma'am Teresa.
Yes. So, good afternoon to all our viewers and listeners, especially to grade 10 learners. Special greetings sa mga hawak kong section, ang 10 Molave, 10 Banaba, and 10 Rizal.
Okay, thank you Ma'am Teresa. And of course, my very own mga Junakis. Okay, so welcome 10 Sinagtala, 10 Obra, and 10 SPJ. And in behalf of Sir Prince, we would like to welcome the science class, no? For this afternoon lesson kasi parang hindi yata makakasali si Sir Prince. Okay, welcome 10 Einstein, Newton, and Rutherford. Okay, so this afternoon, I believe we have a very interesting topic to be discussed. Kasi napakaganda nito and para nga sa akin, this is one of the most enjoyable and exciting topics in physics. Okay, so Ma'am Teresa, will you give us a brief overview of what are we going to discuss this afternoon?
Okay, yes. So, our topic for today is all about qualitative characteristics of images. So, after our discussion, my dear grade 10 learners, you are expected to predict the qualitative characteristics, the orientation, type, and magnification of images formed by plane and curve mirrors and lenses, and identify ways in which the properties of mirrors and lenses determine their use in optical instruments.
Okay, thank you Ma'am Teresa. So my dear grade 10 learners, napakaganda po ng topic natin ngayong hapon. Kaya wag kayong umalis, stay tuned until the end kasi mamaya meron tayong technique na pag-aaralan kung saan, okay, maipe-predict na ninyo later on kung ano yung image na mabubuo sa ating mga mirrors and lenses. Okay, so before we start, may we have a review or recall of our last week's topic, which is all about the applications of different types of electromagnetic waves. Again, the different types of electromagnetic waves are, we have radio waves, microwave, infrared, visible light, ultraviolet, X-ray, and gamma ray. And we have learned that they have different applications in our daily lives. Actually, these electromagnetic waves are very useful in the different fields like in communication, medicine, and other industries. However, too much exposure, most especially to electromagnetic waves with high energy, may also pose danger to our health. Therefore, we should avoid or lessen our exposure to these electromagnetic waves. That's why it is very important to gain knowledge about these electromagnetic waves. Okay, so yun po yung lesson natin last week.
Okay, thank you Ma'am Mirna for that review. Napakamalaman. Okay, this afternoon we will focus on the qualitative characteristics of images formed in mirrors and lenses. So, to discuss the concepts of our lesson, let us welcome our science teacher. So, let's start with Ma'am Teresa and Ma'am Fernandina.
Okay, yes, Ma'am Jen. So, it was discussed in the RBI that images form in the different types of mirrors through reflection. So, when we say reflection, that is the bouncing back of light into the same medium it has been traveling after striking an opaque surface. So, pag sinabi nating opaque, it does not allow object that does not allow light rays to pass through. So, just like when you dribble a ball, once the ball hits the floor, the ball bounces back. Ganun din ang nangyayari sa light rays. Once it hits the surface of an opaque object, light rays will be reflected. Kagaya dyan sa illustration, tignan natin yung figure 1. Okay, so in figure 1, it shows the reflection of light. So the light rays that strikes the surface is called the incident ray. So yun yung pink ray. And the ray that rebounds from the surface, that is called as the reflected ray, the green ray. And the line in between the incident ray and reflected ray, that is called the normal line.
Yes, Ma'am Teresa. So, dagdagan ko lang yung review nung past lesson nung RBI natin kanina lang. Okay, so there are two kinds of reflection, di ba? Yung sabi ni Ma'am Teresa na once light strike a surface, nagkakaroon siya ng parang bumabalandra siya, nagkakaroon ng rays, reflected rays. Okay, so there are two kinds of reflections. We have the regular reflections and we have the irregular reflection. Okay, tignan natin yung nasa figure 3. Okay, so how light rays are reflected. So it shows a regular reflection yung sa figure 3 natin. Sa figure 3 natin. Okay, so it shows irregular reflections, and in figure 4, it shows an irregular reflection. So as you can see, the rays are reflected parallel to each other, or they are in one direction. In regular reflection yon. While in irregular reflection, the group of rays will be scattered in all directions after the reflections.
Okay, yes, Ma'am Dina. And irregular reflections occur in sa mga rough surfaces, just like sa mga walls, floor, pages of a book. That's why they scatter light upon them, kasi rough surface. But in diffuse reflections, it enables us to see things around us. When some of the reflected light reaches and converges in our eyes after diffuse reflection, just like Ma'am Mirna, yung nasa figure 5. Okay, yan. So, when some of the reflected light reaches and converges in our eyes after diffuse reflection, we can able to see the object.
Okay, tama ka dyan, Ma'am Teresa. So, in irregular reflections, it occurs in rough surfaces. Sa regular reflections naman, this occurs in smooth surface. Just like the reflection in the mirror. O kagaya nung nasa nasa PowerPoint natin. Mirror on the wall. Okay, so that is why the rays are in one direction. So regular reflection is the reason why we can able to see image of an object placed in front of the mirror. Kagaya ng base diyan sa figure natin. Okay, so when we say image, that is the visual representation of an object which is placed somewhere in front of a mirror. Yun yung kagaya ng nasa figure 6. Siyempre, di ba, alangan naman nasa likod ng mirror natin ilalagay yung object. Walang mangyayari, di ba? Walang reflection.
Okay, ganun pala yun, Ma'am Mirna, So, dahil sa reflection, we are able to see objects. Okay. So, pero Ma'am Mirna, napansin ko lang, yung mirror kasi na ginagamit natin, may flat surface, pero meron ding curve. Katulad ng sa mga groceries, yung mga nasa gilid-gilid
na malalaki.
Saka sa side mirror ng sasakyan.
Yes, yes, Ma'am Jen. Correct ka dyan, no? Yan, napaka-kin-observer ni Ma'am Jen. Okay? So actually, Ma'am Jen, to answer your question, there are different types of mirrors. We have what we call the plane mirrors and the curved mirrors. Okay, so when we say plane mirror, these are mirrors with flat or planar reflective surface. Yan, yung example yung nakikita natin, no? Okay, so for light rays is striking a plane mirror, the angle of reflection is equal to the angle of incidence. So it follows the law of reflection. Yung pinakita kanina nila ma'am at in-explain nila ma'am Teresa. Okay, another type of mirror is the curved mirror, which follow the surface of a sphere. Okay, kaya sometimes it is called spherical mirrors. Okay, another term po niya yon. Okay, and curved mirrors are further classified into two. We have convex and concave mirrors. So what's the difference between these two? Okay, so the reflecting surface in a convex mirror is the inward part of a sphere. Kung nakinig kayo kanina dun sa ating RBI lesson, okay, ginamit yung spoon, no, to explain or to describe this type of mirrors. On the other hand, kapag concave naman, okay, the reflecting surface in a concave mirror is the inward part of a sphere. Okay, later, mamaya, makikita natin kung ano yung mga mabubuong images with this kind of mirrors.
Oo, kasi ma'am, itatanong ko talaga sa'yo, pareho ba ang image na mapoproduce sa plane mirror and cave mirror?
Okay, okay, actually, yan ay sasagutin ng ating mga anak, di ba? Di ba, Ma'am Jen? Because that has been discussed in our lesson a while back. Okay, so tatanungin natin yung ating mga learners, no, to check their understanding and of course, kung talaga bang sila ay nakinig dun sa ating lesson and nagbasa at nagsimula ng sumagot dun sa ating module. Okay, so my dear grade 10 learners, be ready to give your answers, no? What type of image is formed in a plane mirror? Plane mirror muna tayo, no? Okay, so you comment your answers on the chat box.
Yes. Anong type ng image ang napo-form sa isang plane mirror?
Okay,
Comment
sige.
na mga anak.
Comment na po. Ma'am Teresa, wala ba tayong ano dito?
Ulitin ko ang tanong ha. Type of image. So, i-describe nyo po kung yung image na na-form sa plane mirror.
Okay, so according to Ma'am Teresa, meron daw tayong load na marireceive. Okay, yung first na magko-comment.
Ano ba ito ma'am? Kailangan masabi niya lahat? As in?
Yes ma'am.
Kasi meron tayong ilang type. Okay. So, isa lang talaga. One word lang.
Okay.
Natin. Wala pa. May mga sumagot na pero hindi po yun yung ating
sagot.
Hinahanap na sagot.
Hindi ko makita,
Anong
ma'am.
type? Meron kasing dalawang type ng image. Di ba?
Yes. Okay.
Na na-discuss kanina sa ating RBI. So, kapag plane mirror, alin dun sa dalawa?
Ang nabubuong image.
Ayun, okay, nakita ko na.
Ang alin?
Ayun. Ang kasagot.
Akala ko ang liwanag. Huwag muna.
Ayun. Okay, check ko lang kung siya talaga yung nauna,
Ma'am Jan,
Wait. Oo, siya nga ang nauna. Okay, so, the correct answer is virtual. So, from 10, Nara. Yan,
yes.
si Joanna Eliza May Salvador.
Okay, congratulations.
Anong price niya?
Okay, 50 pesos
50
load
Wow
down.
naman, 50
Naku.
pesos, pang ano na yun.
Ba't parang nahuli yata yung
Pang
anak mo
data
ngayon?
na lang, pang data
Anak,
na.
i-chat mo si ma'am tapos i-send mo yung number
CP
mo
number
sa
mo.
kanya.
Okay.
Si Ma'am Teresa. Hindi, kahit
Okay.
sino sa amin na lang.
Ayan. And mama, marami ring sumagot. Okay, napakaraming sumunod na mga kasagutan. So it means to say na
Yes.
talaga namang nakinig sila sa ating
Oo.
lesson kanina.
Ayun,
on the air
virtual.
lesson.
Daming sumagot.
Yes. At galing sila sa iba-ibang section. Okay. So, congratulations. So, once again, Joanna. And the correct answer is virtual. The image formed in plane mirror is virtual, same size as the object, same orientation as the object, and same distance from the mirror as the object. Pero yan ay ating papatunayan mamaya. Meron tayong gagawin, di ba Ma'am Jen? Papakita yan ni Sir Ronnie. Okay, yung tinatawag nating ray diagram. Okay? So,
pero bago yan, okay, pag-aralan muna natin yung mga key terminologies.
Yes.
Okay. Na magagamit natin paulit-ulit sa lesson ngayon. So, we have mirror terminologies. Curve mirror terminologies with Ma'am Teresa and Ma'am Dina.
Okay, thank you Ma'am Jen. Okay, so sabi nga ni Ma'am Jen kanina, kailangan mo nang alamin natin what are those key points or mga important points or important concepts or words na magagamit natin in ray diagramming. Maganda ito maganda itong lesson na ito talaga. Okay, so the first one, we have the vertex. It is represented with capital letter V, vertex. O, nakikita nyo ba yung nasa screen natin, mga anak? Okay, so pag sinabi nating vertex, this is the middle point of a curved mirror. Paano na ba yung curved mirror, Ma'am Teresa? Di ba yung sa curved mirror, ito yung, paano ba yun?
Okay, so in curved mirror, hindi siya flat.
Yes.
Flat.
Oo. Hindi siya, kasi curve siya. Di ba? Curve siya talaga.
Part of a sphere.
Yes.
Kaya tinawag na spherical mirror.
Yes. Okay. So, Ma'am Teresa, what is the second?
Okay, so another term na kailangan natin sa ray diagramming is center of curvature, which is represented by capital letter C. Okay, so if the mirror extended to be a circle or a sphere, kagaya dyan sa nasa screen natin, yung broken line, yung center of curvature would be the center of the sphere.
Okay, so center of curvature yun ha. Kung buo sana yung mirror natin na pabilog, pa-circle. So yung pinaka-center niya, yun yung the center of curvature. Okay, another term, we have the principal axis. O, hindi siya principal sa spec ha. Principal axis represented with capital letter PA. Ay, si Papa. Pa. Okay, so principal axis is an imaginary line. O, nakikita nyo dyan sa ano natin, sa screen natin. Okay, an imaginary line drawn through the vertex. So, from the vertex, perpendicular to the surface of the curved mirror. O, nakikita siya doon, maliwanag siya na nakikita doon sa may screen natin. Okay, then the last one, Ma'am Teresa.
So another, we have the principal focus, represented by capital letter F. So that is the point between the center of curvature and the vertex. Basta nasa in between the center of curvature and the vertex. And it is the point where the reflected rays meet, as in the case of concave mirror, or the point where the reflected rays seem to come from behind a convex mirror.
Okay. So, yun po yung mga dapat nating tandaan. Yung mga terms na yun, we have the vertex, we have the center of curvature, we have the principal axis, and we have the principal focus. Huwag nating kakalimutan ang mga yan kasi magiging helpful ang mga yan. Para dun sa
kailangan natin 'yon sa ray diagramming.
Yes, sa pag-locate, 'di ba? To explain pag-locate ng nasaan nga ba yung image?
At anong
Okay.
klaseng image?
Yes. Anong size ng image? Mas malaki ba siya or the same lang?
Yes.
So we're going to use the acronym LOST. LOST. Nawawala. Yun ba yun? Okay. So, Ma'am, ano po ng PowerPoint natin? Okay. Okay, so now, the first letter is letter L. So, it stands for the location of the image. The distance from the mirror surface. So, nasaan nga ba yung image? Pag tumayo ka sa harapan ng mirror, nasaan kaya yung image na ma-form? Andun kaya sa likod ng image? Nasa side or nasa tagiliran ba? Okay, so kailangan natin yan.
Okay,
Location of the image.
Yes, Ma'am Dina. So when we describe the image, so we describe it in terms of its lost, L-O-S-T. So L stands for location of image. Sa O naman, orientation of image. So pag sinabi nating orientation, ano ba siya? Upright or inverted yung image na na-form. Pag sinabi nating upright, patayo. Then, pag inverted, dear learners, pabaliktad yung image na na-form.
Oh, yes, Ma'am Teresa. Upright or inverted. Pag nagsalamin kaya ako, Ma'am, ano kayang magiging ano ko doon? Wala, baka
image
naman
na mafo-form.
ikot, di ba? Baka inverted na ako. Okay, so the next letter is S. Okay, the size of the image. Ano kaya yung magiging size ng image? Halimbawa, tumayo ako sa harap ng mirror. Ano kaya, kapantay ko kaya, the same ng size namin, yung, halimbawa, yung taas, dun sa ako at sa image ko. Or, mas mataas kaya?
Maliit kaya?
Or, yes, or mas maliit kaya siya sa akin. So, depende yan, di ba? So, malalaman natin lahat yan mamaya, dun kay Sir Ronnie.
Okay, then another, we have the T, which stands for the type of the image. So, na-discuss yan kanina, ano yung type? It can be real or virtual. So, a real image is formed when the light actually arrives at the image location. Pero sa plane mirror kanina, always virtual ang image na mako-form.
So, always virtual yon. So, wag natin kakalimutan yung ating acronym na LOST or L-O-S-T. Magiging ano yan, magagamit natin yan in describing the image form. Okay, so Sir Ronnie, andyan na si Sir Ronnie para mas lalo nating paano kaya gagamitin itong sinasabi nila na ito?
Lost.
Okay, ma'am.
Yes. So, how can we determine the location, orientation, size, and type of image? So, we can determine that using the ray diagram na i-discuss ni Sir Ronnie.
Hello po. Hello. Okay na. So, in the ray diagram for concave mirrors, we use three principal rays to construct images. An image formed where the rays converge. Okay, susundin natin itong three steps or reminders muna for in drawing the concave mirror ray diagram. First, use an upright arrow to represent an object. May mga may mga books or may mga sources naman na hindi arrow ang ang ginagamit. Yung iba nilalagyan ng candle or yung iba naman nilalagyan ng puno or ng tao. So depende sa gumagawa ng ray diagram. Pero dito in this lesson, we will use arrow, upright arrow. Number 2, show real rays as a solid lines. So yung mga real rays, yung matatama doon sa mirror, yun ang solid. Then the use dashed lines to represent or to present virtual rays, which are rays that only appear to exist behind the mirror. Next slide, ma'am. Okay, step 1. Basahin ko muna yung step 1. Draw a ray starting from the top of the object parallel to the principal axis and then through F after the reflection. Next. Basahin ko. Okay. Tama ba yung drawing, ma'am?
Wait lang, sir. Wait lang, sir. Pakita ko sa'yo yung isa.
Ma'am, pwedeng ako na lang po mag-share.
Ay, okay, sir. Sige, sige.
Okay po. Cheers. Wait lang po. Okay. So, nakikita natin ito. We will use... Okay, ma'am, okay po ba itong natin? Itong... dito. Okay po ba?
Nag-share si Sir Ron.
Share siya? Oo. Kasi iba yung gamit niya sa
Share screen si Sir Ronnie, sir.
Okay na po ba?
Sir Ronnie, di ganong makita.
Ay, di ka na makita. Yan.
Ayun. Sige, sir. Sige.
Hindi pa rin?
Sige, sir. Okay lang.
Okay. So, we will use the first step. Alisin muna natin itong ray 3, ray 2. Dito sa case na to, ang ginamit po natin ay F and 2F. Kasi sa ray diagramming, yung 2F, it represents the center of curvature. Huwag yung makalimutan na. Kasi kanina, C po ang ginamit doon. Pero sa sa actual ray diagramming, ang ginagamit karamihan ay 2F. Which means, paras din yan sa center of the curvature. So, mapapansin natin yung first one, sabi first step, a ray starting from the top of the object parallel to the principal axis. Ito po yung principal axis natin. Tama? It's the principal axis. And this is the ray traveling to the principal axis and then reflect through F. So, mapapansin nyo, magre-reflect siya through F. So, ito yung first line ray natin. Second, ray 2. Ito yung ray 2 natin. Sabi sa ray 2, muna.
Ako na lang magbasa nung sir, para hindi ka mahirapan. Nung step 2.
Sige, ma'am. Ray 2.
Okay. So, step 2, F2P ray. Draw a ray starting from the top of the object through the focal point, then parallel to the principal axis after reflection.
Okay, ulitin natin na yung ray 1. Ito yung ray 1. From the top, parallel to the principal axis, magre-reflect siya sa focal point. Ito namang ray 2. Ray 2 lang ipapakita ko. Okay, ito yung ray 2. Mag-travel siya sa focal point. Ang reflection niya naman, parallel sa principal axis. So, yun yung ray 2. Next, ma'am, yung ray 3.
Ako na. Okay. So, ray 3 is the CC ray. Okay? Draw a ray starting from the top of the object through C. Then back upon itself.
Okay, act upon itself. So, yan po siya.
C or 2F.
Oh, C or 2F. Now, so, mapapansin po natin, itong tatlong ray diagram natin. Bakit hindi siya makuhan? Wait lang po. Madali lang. Hindi na siya magalaw. Okay.
Nasa B-ray ka na.
Okay, ito na po tayo. Okay. So, nasaan yung image natin? Ay, nasaan yung object natin? Behind the center of the curvature. So, ito yung image natin. Saan mabubuo yung image natin? Ma'am Jen, saan nabuo yung image natin?
So, kung ang ating object ay nasa likod or beyond our center of curvature, ang ating image ay ma-form or na-form between the center of curvature and the focal point.
Okay. Yan yung tinatawag nating L, yung location niya. Tama? Di ba may loss kanina? Yung location?
Yes.
Okay. How about the orientation, Ma'am Jen?
Okay, so kung mapapansin natin yung kandila, okay, dun sa image natin, nasa baba na yung kanyang apoy or yung sindi niya. So, bumaligtad yung ating image. So, it is now inverted.
Okay. Yun, tapos na tayo sa L, tapos na tayo sa O. How about the size?
Okay. So, compared to the size of the object, our image is smaller.
Then, what is the type of the image, ma'am?
Okay, since the object, the rays are real, real rays, okay, actual rays, I should say. The type is real.
Okay, very good, ma'am. Thank you, ma'am Jen. Dito ginagamit yung ray diagram para ma-apply natin yung LOST. Yung binanggit kanina ni Ma'am Dina na yung location niya, orientation, size, and the type of the image. Ngayon, kung ipupunta naman natin itong image sa mismong F, 2F means center of curvature, tapat niya mismo yan. So, the same process. So, nasaan yung location ng image, ma'am? Ma'am, ayan, Mirna. Mirna.
Nasa, mali, wag ka delayed yan.
The location, yes,
Okay,
the location of,
hindi niya makita. Nasa C, sir, yung ating object?
yes, nasa C.
Ang kanyang location is at C or center of curvature, sir. Ang
Yes,
kanyang
yes.
orientation ay inverted. Inverted. Pasensya na po, medyo mahinang aking mata. Okay, ang kanyang size ay the same with that of the object. And
it is real.
It's a real image.
Okay, thank you very much. So, ganyan po ginagamit yung ray diagram natin. So, mahalaga lang gumamit tayo ng 3 rays para mabuo natin yung image. So, back to you, ma'am.
Okay, thank you, Sir Ronnie. Okay, my dear learners, no, meron dyan yung step natin for the ray diagram technique. Okay, sundan lang natin yon. And makikita ninyo kahit saan natin ipe-place yung object, pag sinundan mo yung technique na yan, you will be able to predict yung ating loss, the location of the image, yung ating orientation, the size of the image, and of course, what type of image is formed. Gaya nung ginawa ni Sir Ronnie kanina. Okay, dalawa yung binigay niya na example. Di ba,
Yes.
Ma'am Jen?
Ma'am Mirna, gusto ko lang idagdag kasi kanina sa RBI narinig ko na kapag ang ating object ay placed at the focal point, there will be no image form. So gusto ko lang makita kung totoo, kung totoo ba 'yon.
Okay, yes ma'am. Sige, bigay pa tayo ng isa pang example. Okay, in addition to what Sir Ronnie had shown.
Ayan Okay, so gamitin din natin yung ginamit ni Sir Ronnie kanina. So kung makikita nyo, the rays, ilan to? 1, 2, dalawang rays ang nandito ngayon. Actually, there are 4, pero pwede mong gamitin 3 lang katulad yung ginamit ni Sir Ronnie kanina. In this case, it's 2. Okay, but we can see that the rays here are parallel with each other. Take note, mga anak, there will be image formed only when the rays meet.
Oo.
So kaya wala siya.
So yan, yung ano nga natin kanina is kapag gumamit tayo ng dash line, no? So ibig sabihin there's no image.
Oo, kasi parallel nga. 'Di ba ang parallel natin sa math is
hindi talaga sila
never silang magtatagpo.
Okay. Hindi katulad ng alam niyo na. Okay.
So yan. Pakita natin kapag between vertex and focus focal point siya. Merong mafo-form pero nasaan na siya, Ma'am Mirna?
Okay, so
Ma'am Tere, yes.
Behind the mirror na siya, Ma'am Jen. And makikita natin yung na-form na image, it is erect, upright.
Yes. Unlike kanina,
about the size of the image, ma'am.
Okay, yes. For the size of the image, as you can see, it is larger than the object placed in front of the mirror.
Okay. So, ano na siya ngayon, ma'am? Anong type na siya ngayon?
Okay, so since it is behind the mirror, so it is virtual image.
So ayun mga anak it's very important that you know yung kanina yung mga terminologies na diniscuss, and of course the process of the ray diagram. Okay, and you will be able, sabi ko nga, to predict the images formed in mirrors natin. Okay, so that is all about the mirrors. How about, okay, so meron pa tayong isang topic na napakaganda rin. Okay, we have the lenses, no? So, Ma'am Teresa, take it away.
Okay, so napaka-interesting ng topic natin. So, I hope, dear learners, na nasundan ninyo yung ray diagramming. So, this time, let us talk another object which plays a vital role in the study of the behavior of light, which is all about lenses. Okay, so have you seen a lens, dear learners? Okay, so ano ba yung mga objects, mga materials na ginagamit natin na may mga lenses? Okay, so pag sinabi nating lens, that is a transparent substance of glass, or it can be plastic bound by two surfaces whose at least one surface is curved. Okay, so at least one surface is curved. So ano ba ang pagkakaiba ng lens sa mirror na ginagamit natin? Okay, so for mirror kasi, di ba, that is opaque. That's why, anong nangyayari sa light rays once it strikes the surface of the mirror?
Nagre-reflect.
Okay, so it will be reflected. While in lens, that is transparent. Meaning, pag sinabi nating transparent, it allows light rays to pass through. That's why, anong mangyayari sa light rays after as it pass through the lens? Okay, so ang mangyayari dyan, it will bend. Ang tawag natin dyan is refraction. Okay, so yun, ang pagkakaiba ng mirror saka lens.
Yes, Ma'am Teresa, yun yung pagkakaiba ng mirror sa lens. Okay, yung sa lens kasi parang yung, alam niyo yung, di ba, you are familiar of magnifying lens? Tama ba ako?
Yes, Ma'am Dina. Ginagamit nila yan sa biology.
Yung ano din, yung mga eyeglasses natin.
Oh, yes, ma'am.
Example of lenses ang mga yon. Okay, so lenses also come in two types. So there are two types of lenses, kagaya ni mirror. So we have also what we call the convex, or what we call the converging, and a concave or a diverging lenses. So convex lens curve outward, while concave lens curve inward. O, nakikita nyo ba dyan sa ano natin, sa screen natin, yung convex, ano siya, parang buntis, tama ba? Okay, while yung
bulging siya.
Convex, oo. Maano siya sa edge niya, tapos habang dun sa gitna, parang nag-bulge siya.
Sa gitna. Thicker sa gitna.
Oo, then pag concave naman, cave, ano ba yung cave? So, meron ng baliktad na. Yung isa buntis, yung isa kanina, ay yung sa concave, ano natin describe ngayon?
Okay, payat sa gitna. Thinner at the middle compared to its edges.
Yes. So convex lens curve outward, while the concave lens curve inward. Paano ba natin tatawagin yon? Buntis at saka Ma'am Mirna? Kasi ang convex, parang buntis siya, di ba? O ano naman yung concave? O yun yung ano natin, i-research natin kung anong pwede natin itawag yan. Okay. So, convex lens is thicker at the center as compared to its edges, while concave lens is thinner at the center compared to its edges. When these lenses are combined, the produced lens is called the meniscus lens. Meniscus lens has one concave and one convex lens on opposite sides. Okay. So, ayan ayan na. Next mo nga siya, ma'am. Next. Yung sa types of
Yan, yung types of
the
converging lenses. Okay, so tignan natin yung unang figure. Both sides of the lens are curved outward. So, ang tawag natin dyan is double convex lens. Pag naman, flat sa isang side, tapos yung isang side is curved outward, that is plano convex lens. Then we have also converging meniscus lens. Okay, so yung biconvex or double convex lens, usually ginagamit yan sa mga magnifying glass, Ma'am Dina, diba?
Yes, ma'am, yes. Saan na tayo? Okay, so converging, diverging. Okay, so concave lens have different types also. These are the biconcave, the plano concave, and the diverging meniscus lens. Okay, so convex lens is also known as the converging lens because as you can see in the illustration, as
natin yung illustration, Ma'am Dina, yung bakit tinawag na converging lens ang convex lens. Ito.
Yan.
Baba, Ma'am Mirna. Sa baba pa.
Sige pa po. Sige pa.
Nawala yung pwede na rin yan na gamitin. Ay, sige,
okay.
Okay, pwede na rin yan, Ma'am Dina.
Yes,
yung
yes,
convex.
Convex muna. Okay, yung sa convex lens, it is also known as the converging lens. Bakit siya tinawag na converging lens? It's because, dun sa may figure natin, kung makikita natin, as light passes through the convex lens, its rays bend inward and converge at the focal point. Tignan nyo.
Okay, so the rays meet at one point.
Yes. Yun yung convex lens. Okay, how about the concave lens, Ma'am Teresa?
Okay, sa concave lens naman, as you can see in the illustration, okay, so the light rays diverge. Pag sinabi nating diverge, they spread out. Okay, so they diverge after refraction. Kaya, tinawag na diverging lens ang concave lens.
Nakita nyo ba yung pagkakaiba? Diba? Sa convex lens,
converging.
nag-limit sila at a certain point. Baga, agsama-sama dapay lang. Okay, for the concave lens naman, habang yung light, baga, meron na silang
refract.
Yes.
Okay,
meron silang kanya-kanyang maghihiwa-hiwalay sila.
They spread out.
Yes, they spread out. So convex lens forms real images and virtual images depending on the position of the object. Okay, so nakadepende yon kung real ba siya or virtual siya, kung nasaan nakaposition yung object natin. Sa mga convex lens yon. For concave lens naman, all images are erect and reduced. So para nakaano siya talaga, hindi siya inverted. Pero mas maliit na dun sa original size or dun sa object, yung image na form. Tama ba ako dun, ma'am?
Yes. So, tandaan yun, mga learners. For concave lens, all images are erect and reduced.
Yes.
Sa convex naman, depende dun sa position ng object. Okay, so it can be
virtual,
forms a real or a virtual images. Okay, maganda sana pag ipakita natin yan sa ray diagram, Ma'am Dina. Kaya lang, kulang na ang time natin. Okay, so hindi na kaya ng time natin. Pero at least, alam na ninyo kung paano ang mag-ray diagram, dear grade 10 learners.
Okay.
Ayan, yung sa picture dyan na nakikita, ma'am, no? Ayan, Dun sa una, dun sa ating
Concave.
convex. Okay,
Convex.
kung papansin nyo, yung ating image ay, ayan, no,
Enlarge.
lumaki, enlarge, no?
Magnifying lens, di ba ma'am? Lalaki siya.
And then, dun sa ating concave naman, ayan, sabi nga niya, all images are erect and reduced.
Reduce.
Parang,
Lumiliit.
Reduce, meaning lumiit yung
Image.
Okay, so parang sa mirror din, no? Depende po sa location. Of the object.
Yes.
Yes, sa concave mirror.
Yes.
Kasi sa convex mirror, ma'am, always na smaller and virtual,
Yung kayang
image
image.
na mapo-form.
Okay, sige, papakita na lang din natin, ma'am, no? Yung ating ray diagram for lenses. Okay, for the information of everybody, yung amin pong ginagamit ay
Physics classroom.
Okay, physics classroom.
Pwede nyo po
Okay,
itong
yung ating
i-access sa
simulation.
Google, i-search nyo lang physics classroom, then type nyo ang mirrors and lenses. Then papakita niya na yan, launch simulation, sabi niya yan. Tapos
Okay.
click nyo lang. Pwede nyo itong paglaruan.
Okay,
Okay,
para
so ito,
para mas matandaan nila, no, Ma'am Jen. Okay, lilipat nila yung location ng object and then makikita nila yung image na mabubuo. Okay, so credits po sa ating PET simulation.
hindi siya pet.
Ay, ano ba?
Physics classroom.
Okay, physics classroom.
So ito po yung example ng converging lens. Ayan.
Yung dentis.
Okay, so yung ating image ay nasaan siya?
Okay, so ang ating image ay nasa harap ng mirror.
Okay, yes.
Okay, then ayan siya, reduce and upright siya. Pag naman diverging, ayun siya. So try lang natin ilipat yung ating So pag diverging, always na smaller siya.
Okay, so ayan.
Ayan, sinabi ni
Dandahanin mo
Ma'am
lang, ma'am.
kanina.
Isa-isang location lang. Okay, so ayan.
Ayan. Ayun
Okay.
siya. Lalo siya. Habang lumalayo, mas lalong lumiliit yung kanyang object. Ay, image. Ay, pala. Okay. Kanina sa converging. Okay. Pag nasa focus siya, yung image ay meron, pero malayo na. Hindi na siya ma-reach. Ayan. So, ito siya.
Unreachable.
Okay.
Okay, so ayan dear grade 10 learners, kung kayo ay may ability na mag-access, okay, i-access po natin yung ating physics classroom.
Yes.
Okay, makakatulong po sa atin yan.
Okay, balik tayo sa slide.
Okay, so thank you Ma'am Teresa and Ma'am Dines. Okay, and now may we have the applications of mirrors and lenses. Okay, Sir Ronnie. Sir Ronnie. Ayan.
Okay, ma'am. Sige po. So, dito na sa application ng mirrors and lens. Mirrors lang sa akin. So, everyday yan kasi ginagamit natin ang na-encounter natin yung application or gamit ng convex mirror. So, convex mirrors allow to see a wider view. They're often used for security in store as well as to the rear view mirrors in car. So, ginagamit sa sasakyan, yung side mirror niya, then sa mga supermarket. So, ma'am, kaya pag sa supermarket, nakikita natin may mga mirror dun sa taas para makita. Mas convex mirror yun mga yun. Samantalang ang concave naman, concave mirrors are spherical designed to collect light and bring it to a single point. Concave mirror used in telescope, flashlight, car headlights, dental examinations, and other applications. So, yun yung gamit ng concave and convex mirror, ma'am.
Okay, thank you, Sir Ronnie. So, ayan my dear learners, as you can see, very applicable and we always encounter the use of mirrors. Okay, syempre sa bahay natin lahat tayo may flashlight, yan, mga cosmetic mirror, syempre. Yan, and of course, dun sa ating mga headlight ng ating car. Okay, so may we have also the application of lenses. Okay, sige, Ma'am Jen, mauna ka na.
Okay, so one application of lenses is the use of microscope. Okay, so alam naman natin, microscope is used in viewing small objects and microorganisms that are impossible for an unaided eyes to see. Okay, it uses lenses that can magnify 100 times or even more than 1,000 times. Ayun, so gumagamit yun ng multiple lenses sa loob para ma-magnify yung ating specimen na undergoing study. Ayun.
Usually, Ma'am Chen, sa microscope, ang lens niya nasa eyepiece and
nasa
sa
eyepiece.
objectives.
Objective.
So, hindi lang isa ang,
Yes, ma'am.
ang lens dyan.
Okay, yes, ma'am. And I believe yung ating mga grade 7 learners during the face-to-face learning, no, they use microscope
Yes,
in biology classes. Okay, another use is camera. Okay, camera uses convex lenses where light pass through. Yan, these light rays are directed towards the slanted mirror located near the camera shutter and then reflected from a translucent screen projected to another mirror until it reaches the viewer's eye.
Yes. Then another application is telescopes and binoculars. So kanina kung sa microscope ay pinalaki So pinalaki niya yung image. So dito naman it also focuses on the objects that are too far for our eyes to see. So ma-magnify niya din yung view. Okay, para makita mo.
Yes, ma'am. Ito ay ginagamit sa astronomy.
Yes,
yan,
astronomy.
Kalimitan, no? Okay.
Okay, sa mga sa mga hunting.
Oh, yes. Sa military. Ayan. Paggamit ng telescope. Binoculars. Okay. Another, of course, concave lenses such as eyeglasses and contact lenses are used in correcting myopia. Ano ba ang myopia? Okay, that is yung nearsightedness.
It's
a condition. Eye
condition.
It's an eye condition in which light rays focus in front of the eye's retina instead of on the retina. The result of this condition is it makes distant object to appear blurry while near objects appear normal. Okay, so nearsighted.
Actually, ma'am, itong nearsightedness is usually sakit ng mga kabataan ito. Kung saan, kung makikita ang sintomas nito kapag nagbabasa na sila ay nakaganyan na, ang lapit-lapit. Kasi yung kanilang eyeball ay naging elongated.
Yes, too long.
Oo.
And the image focuses in front of the
Instead of the image will focus on the retina, nasa harapan siya, nagfo-fall. So, blurry ang doon. So, kailangan nilang palapitin yung kanilang object para mag-focus dun sa may retina nila.
Okay, yes, Ma'am Chen. Okay, so meron tayong mga concave lenses na ginagamit and contact lenses, no, to correct that eye condition. Okay, meron pa tayong isang eye condition, ma'am.
Yes, we have far-sightedness or we call that hyperopia. I-condition din ito ng mata wherein the eyeball are shortened. Ito naman po ay kadalasan nakikita sa mga ating mga elderlies. Ayan. Yung magbasa sila ang nilalayo nila ganyan. Ganyan sila. Okay. So, sabi dyan, eyeball is too short, so image is focused behind the camera. So, gumagamit tayo ng lens na kung saan ilalapit niya yung image or yung location ng image, ipo-fall niya doon sa retina natin. Kasi yung retina siya yung nag-serve as screen sa ating mata.
Okay, yes ma'am. Yes ma'am Jen. Okay, so there are more applications of both mirrors and lenses. Okay, so marami pa. Pero baka abutin tayo ng 9 o'clock kung lahat yan ay i-discuss natin. But at the end of the day, makikita natin na itong concepts na ating pinag-aaralan ngayon, the concepts and that were discussed and presented to you are all beneficial in our daily lives. Okay. So, Ma'am Teresa, will you give us a brief summary of what we have discussed today?
Okay. So, I hope, dear learners, na marami kayong natutunan sa ating lesson ngayon. Okay. So, na-discuss natin yung different types of mirrors. Wherein we have the plane and curved mirrors. And the images formed in these different types of mirrors. And also, ray diagramming. Okay, so we have also discussed the about lenses, the different types, convex and concave, and the different applications. Okay, so sana marami kayong matutunan at makakatulong ito sa pagsagot ninyo sa validating questions and sa inyong summative test, mga anak. Okay, so don't forget to answer your validating question and summative test.
Yes, Ma'am Teresa, thank you for that reminder kasi kalimitan nagiging problema sa ating mga anak. Nasasagutan nila lahat yung mga activities sa module, but then wala silang isinasubmit na validating questions and summative tests, which are very important.
Plus yung performance task na
performance
ibinibigay
task
ni teacher.
Okay, so I believe later on may bibigay tayong performance task
Yes,
sa bawat
meron
sa
na nakahanda.
klase natin sa ray diagram.
Oo.
Okay. Okay, so with that, okay.
Thank you sa inyong participation and congratulations sa nanalo kanina.
And of course, congratulations sa lahat ng ating learners dahil sila ay natuto na naman ngayong hapon.
Oo, yun ang Okay, so bago kami magpaalam, we acknowledge the people behind this RBI airing. Okay, so syempre ang ating scriptwriter ng ating ang ating RBI for this week is Ma'am Teresa Senica. Okay. So, hello ma'am.
And of course, yung ating radio teacher, tama ba si Ma'am
Yes,
Benjelo?
ma'am, yung ating radio teacher.
Ma'am Benjelo Paraiso.
Naamay ko na ang
And we would like to take this opportunity, Ma'am Benjulo, to ipaalam ipaalam namin sa buong mundo ang iyong bukas. Okay, very special day. So, Ma'am Benjulo, congratulations.
And best wishes.
And best wishes. Ayan.
Okay. Maraming salamat po sa ating officer in charge, our Chief Education Supervisor, Sir Rodrigo V. Pascua. Sir, thank you to our Assistant Principal, Ma'am Ruby Guillermo, to all the head teachers, especially the head teacher of Science Department, Ma'am Annabel Rodriguez, and to all science teachers out there, to all science enthusiasts, maraming salamat po sa inyong
And of
patuloy na
course,
suporta.
yes, and of course, syempre, nakakalimutan ng ating napakasipag dito na technician natin, si Sir Jashel Guillermo. And of course, ang ating floor director, yung ating director, Sir Dennis.
Ang punong abala.
Punong abala. Ayan, Sir Dennis Mendoza. Okay, so once again, thank you very much, dear grade 10 learners, and see you next week.
Okay.
Physics, chemistry, earth science, biology, biochemistry, environmental science. These are some branches of science. Science is about a whole lot more than that. And to sum it up, we believe that science is the way of helping the brain grow in finding new knowledge and help us defeat our curiosity and how the world develops and works today. Science. This is your class, and this is science. And now, here is your host for the day. ito ang 106.3 Dance Radio. Dance Radio.
Prepare yourself.
Ang silid-aralan sa radyo, hatid namin ay makabagong paraan ng pagtuturo at kalaman. Mapaumaga, tanghali o hapon man yan, ang istasyong magbibigay impormasyon kahit saan man.
For something big.
Alright, here we go.
106.3 Dance Radio. Doña Aurora National High School, Santa Rita, Aurora, Isabela.
This
106.3 DWBR FM.